This is the superposition theorem, girls. I think we need to start from here, correct? Superposition theorem. Okay. So this is the statement of the superposition theorem. The superposition theorem is a way to determine currents and voltage in a linear circuit. Okay, yani we can find voltage and current in any component, any resistance that has multiple sources. Now here we can apply superposition theorem where we have multiple sources. All right, and how we are going to approach? By taking one source at a time. Means there are multiple, but we will consider one source at a time and we will calculate voltage and current in that particular resistance. Later on we will consider another source, okay, then calculate again, then finally we'll algebraically summing the results. This is how we will use superposition theorem. So this is the step to apply the superposition theorem. See now. So let's consider this is a circuit given, multiple sources. You can see two voltage sources are given, and we are interested to find this I2. All right. So here we will consider one source at a time, as I told you. So we are considering VS1 and another source because it is a voltage. So it is gonna be short circuit. All right. Now, so after when you make it short circuit, we need to still we need to calculate this I2 still. So we can say this time either this is I21. Why 1 I am saying? 1 yani I am considering voltage source 1. That's why. Okay. Then you know that the conventional method which we applied earlier, we need to find the total resistance. After getting the total resistance, we can calculate the total current. So this is total current. So again, rather than saying just IT, I can say IT1 or I can say I2S1 because this is the total current when I considered source number 1. All right. After calculating the total current, which is, you can see how you are going to do this one. R2, R3 is in parallel. Then later on it is going to be in series with R1. So this way we'll be getting total. Okay. Then if you divide the voltage source voltage divided by this one, you will be getting total the current. Now, once you get the total current, you can apply here current divider rule, which you already applied many times. So this is I2S1, which we need to find now. So you know that total current is flowing here, which is I2S2, S1. Okay. So here the formula is simple. R3, which is here, divided by R2 plus R3 multiplied by this one. So this way you calculated the current which is flowing in R2. It is because of the source 1. All right. Now same thing you have to repeat. Provided one thing which you need to consider, that because we are saying the current is flowing from up to down, and same if we are considering for another case like this one, current is flowing up to down. So it means we need to add them algebraically. All right. So now we are proceeding for second. You see this one, and this time R1, R2 is in parallel. Later on it is in series with R3. So this is the way to calculate the total RTS2. Then we will be calculating RTS2 total current here. Then finally we'll be applying current divider rule here, and we will be calculating the I2S2. Now because both the current directions are up to down, so simply I2, this is the what you call overall current which is flowing because of both the sources, I2S1 plus I2S2. Bas, this is the way to apply superposition theorem. In case of any voltage source, we have a current source, so we will open that current source, and while another thing will be everything will be same. This is the way. So hope it is clear from this diagram, all the steps. Now let's consider one example. So let's suppose you have given this picture and we just want to know if we put here a meter, how much this ammeter will read. So you can see this is a complete circuit, and definitely if we just simulate this one in false state, we can see how much it is gonna be read. But we can also calculate by applying the superposition theorem. Okay, so what does the ammeter read for I2? Okay, so we will calculate this one, and what we are going to do, we will consider one source at a time. So let's suppose we are considering this one. So this is gonna be short now. Okay, now after that you need to calculate RTS1. So calculate this one, girls. RTS1 formula is clear to you already, how they are connected. So you can say simply RT, I'm saying RT1 or RTS1, whatever. So R2 is parallel with R3. All right, first it is the way, then it is gonna be sum with R1. Calculate this much, how much this you are getting. Those are in parallel. You can see simply they are equal value, so their value will be half exactly, that is 3.4. so you can say 3.4 plus 2.7, just add it. Yeah, 6.1 kilo ohm. This is the way. Okay, now you can calculate IT1, which will be simple VS1 divided by RT1. Okay, which is 1.9 milliamps. All right, now so we will consider another source, because no, sorry, this is IT1. So now we need to apply the current divider rule, and we need to calculate I21. And do you know one interesting fact? Okay, this is 6, huh? Okay, and you can see the current which is flowing total, which will be flowing here. Okay, it will split into two parts here. One will go in R3, another will go here, and you can see both resistance are of same value.
Equal.
So yeah, it will be divided equally. So it is gonna be something like this.
0.98.
0.98 milliamps. All right. So this is we done with one step, yani by considering one source. Now another point is that we need to consider next another source. So what is the value of another source? Just a minute. If I click somewhere, it will go. Can you check what is the value of another source so that I can continue calculations here? Do you know? Anyone have slides?
Well,
Another one is also 12. Okay. All right. If it is solved, no problem. So another one is 12. So this one is gonna be short. You know that, okay? So at that time we need to calculate the total resistance again first. So this time we will give the name 2, okay? And you will see at that time R1 will be parallel with R2, and it is gonna be series with that one. Now calculate this one. R1, R2 will be in parallel, right? Okay, 8.73 K. Okay, after getting this, we can calculate IT2, which is simple VS2 divided by RT2. So 12 divided by this one. Okay, 2.06 milliamps. Yeah, it will be 2 point, because 12 over 8, no, 1 point. It will be 1.76. Yes. Yeah, it should be 1.37. Okay, then after getting this one, we need to apply the current divider, and you know that the current is flowing because this source is there, so current will go up and it will reach here, then it will split here. So again current will go up to down. So I can say simply this time again, what, IT2, not IT, I22. Okay, I22 yani I2 because of 2. This should be 18 volt. Yes. Okay, some changes there. So if 18, so just calculate then accordingly. Okay. Guys, so V2 is 18. Okay, check it this one. 2.06. Okay. Now, so we need to apply here current divider. So current divider, R1 over R1 plus R2 multiply by the total current. Calculate then this one. Okay, 0.58 milliampere. Now you can see this current is basically flowing up to down, and another one is also up to down. So the final I2, we will say that I21 plus I22, which you will add here to 0.98 plus another one 0.58. Just add them and get the value. 1.56 milliamps. So this is the overall current which is flowing in this circuit. Similarly, if we ask to calculate the voltage, okay, you can also calculate the voltage. Okay, how can you calculate the voltage? Yani once you get this current here, can you get the voltage also here or not? Voltage will be what? We can say V21. Okay, and we know the already current. We will multiply with the resistance. Okay, which is 6.8. So you will get this one. Similarly, once you get this current, you can also calculate here V22. Okay, and then finally you need to add both the voltages. Same. Clear point?
Clear.
Okay, so this way you can apply the superposition theorem and you can find the current. But yeah, definitely it will take some time, so you cannot be hurry, but with the practice you will know these things. So these are the values. So let's see what are the values here in the table, is matching with you or not. So total resistance, yes, correct. 1.97 correct. 0.98 correct. Second source considered 8.73, 2.06, 5, and final current is gonna be 1.56. Okay, so the total current is the algebraic sum. This is the way to apply the superposition theorem. All right, now see this here. So here you need to apply superposition theorem. So at this time we have one voltage source, one have current source, and they are asking to calculate Ix.
Doctor,
Yes.
can you please go back to the last slide? I will take a screenshot.
This one?
Yeah.
Do you need the values which I was calculating?
You already erased them. So
I think, I don't know whether it can. Oh, this one, yeah?
yeah, that's one. Okay, thank you.
Okay. Background will be same. I think background cannot be. Just wait. No, you can take it this time. Values will be clear now. because of the background that was not clear.
Okay, I did. Thank you.
All right, so yeah, another question is this one. So we need to calculate here Ix. So voltage source is there, current source is there. You have to apply, you have to consider one by one, and you need to calculate the Ix. Let's see this one. Let's see this one. So this is the circuit. Here we need to calculate this Ix. Okay. So we need to consider one by one circuit. So, okay. So let's suppose first we are considering what you wanna consider, voltage or current. Let's suppose if we are considering this voltage source. So current source is gonna be open circuit. Okay. We need to open it. So once I open this terminal, so you can say this wire have nothing to do here once I open it. So this will be a simple bridge, this one. Okay. So this circuit will look like something this way. See this one. This. Okay. So because of why? Because once I open it, so these terminals is open. So either I consider or not consider, no matter. So I just ignore this one and I have this simple circuit here. Now I need to consider Ix1. I need to calculate this Ix1. So in order to calculate the Ix1, you see here how can we approach. So first of all, try to understand how 2 and 4 are connected. Are they connected in series now?
No, in parallel.
2 and 4, they are in parallel.
In series.
They are in series. 3 and 1,
Also
they are in series. Yes, they are in series. So this circuit can be drawn like this. Look here now. So I can draw this one, 6 and 4. So this is the same thing here. Okay. Now, if you look closely, so you will observe that 6 and 4 and this battery, they are connected between two common nodes.
parallel.
Okay. So they are parallel. So 6 and 4 is in parallel. So we can find the equivalent resistance, 6 and 4. So apply the product over sum rule. So this is what? 6 multiplied by 4 over 6 plus 4. Okay. This is 2.4 ohm. Okay. So after getting this, we can redraw the circuit this way. See, but I just changed the direction this way. So current direction is again this way, plus minus and 2.4, because between the terminal, this is now simplified. So now it's so easy to calculate the Ix1 because this is a simple series circuit. So you can calculate here Ix1. And what is that one now? Ix1 is equal to voltage divided by the 2.4. So you will get here 0 and C, you will get here 2.08 ampere. So this is the way. Okay, yeah, 83 or 2.08 ampere. So this way we calculate the current because of the voltage source. Now, second step is we need to consider another source. So second part where we will consider the current source. See this one, considering the current source. So when we are going to consider current source, this voltage source is gonna be short. Okay, and let's say this current is Ix2 now, because that time I said Ix1, now Ix2, and the direction again we are assuming from left to right. So see, the current is given -3 amps. Okay, arrow is showing up, so no worries, because it's showing minus, so we will be considering its value all the time, whatever given minus, so we will be using minus, but direction is giving up. So you see this current will go up and it will reach here, then it is splitting into two parts. So then one part will come here, after reaching here some part will go there, some part will go there. So the point is, if we can calculate the currents in the branches, that will be easy for us. But how can we calculate the current? Because we know the resistance, okay, but if we can find the voltage across this one or voltage across this one, so we can find the current because the resistance is already given. So in order to find the voltage, we need to consider that one more concept, that if you look 2 and 4, they are connected in parallel. Am I right?
Yes. Yes.
Because of this is the short wire, they are connected in parallel. Similarly, 3 and 1 is connected in parallel.
Yes.
So whatever is the drop between their combination, it will be same here and same here, like that. So what we will do, we can redraw this circuit this way. And what it's saying, 2 parallel 4, 3 parallel 1. Getting point?
Yes.
Okay. So they are parallel. So this circuit look like that now. So we will calculate the parallel combination. So 4 multiplied by 2 multiplied by 4 over 2 plus 4, yani 8 over 6, or we can say 4 over 3 ohm. This is the parallel combination. Now for 3 parallel 1, it is gonna be 3 over 4 ohm. Now girls, we know the total resistance, yani this resistance. Now if you look here closely, this circuit is a very simple series circuit, and same current will go to this parallel combination and this parallel combination. Now if I know the current, if I know the parallel value of this resistance, I can find how much voltage drop is here, how much voltage drop is here. So I will calculate how much is the drop here and how much drop is here. So 4 over 3 multiplied by -3, because current value is -3. Once we multiply, we'll get -4 volts. So in this combination, -4 voltage drop is there. Clear?
Yes.
Yes.
Yeah, similarly look for another one. So the resistance is Ohm's law I'm applying simply. Voltage resistance multiplied by current. So 3 over 4 multiplied by -3. When you solve it, you will be getting -2.25. So this way we calculate the voltage across here and voltage across here. Okay, both are negative because the value is given negative. So no worries, you just keep using same. So once we know this is the voltage drop, it means is that same drop will be across 2, same voltage drop will across 4, because they are in parallel, and this is the overall voltage drop. Similarly 3 and 1, they are in parallel. So what we calculate here, then their combination, which is -2.25, it will be same here and it will be same here. Correct now? Is it clear?
Yes.
This point. So because we know now voltage is in each resistance, so it's easy to find the current as well. So now see. So can we apply here, just a minute, KCL. What is KCL? Kirchhoff current law at green point. So at green point, you can see because of current will reach here. So this current is incoming, this current is outgoing, this current is outgoing. So I can apply KCL. So I can say I2 equal to I3 plus ix2, and I can say ix2 is equal to I2 minus I3. All right, then I2 is how much? I2 is how much?
-2.
-2. How it is -2? Because we know the value here, voltage value, right?
Yes.
Which is -4. -4 divided by 2. You will be getting -2 current. Clear this one?
Yes.
So I just put it like that. Now another one is I3, and I3 is this one. And how much is the voltage across this resistance? You can see -2.25. So -2.25 divided by 3 will give you
0.75.
because this is already negative and the current value is negative, so it will become negative, positive.
Yes.
Clear? Okay. Now just add them. When you that, you will be getting -1.25. Clear? Now, so in both the cases, we consider the direction of current flow left to right, left to right. So I will write simple formula. What is that? The formula will be now Ix is equal to Ix1 plus Ix2. So whatever the value, just keep it here, 2.08. Another value is minus value, so keep it as it is. And you will be getting the answer, which is 0.83 ampere. This is the overall current which is flowing in this circuit, which is Ix. Clear to all of you? Okay.
Yes,
So,
clear.
okay, so you can take a screenshot of this solution. Okay.
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 Yes.
So now move to the slide. Okay, so the answer you can check now here. It is Ix is equal to 0.833. So this is the answer, and you get the same. Now, so see, there are many questions in the book, girls, for the superposition theorem. I think yesterday I opened one of the question, then I said it can be solved by the superposition theorem. So you need to apply superposition theorem and you can solve many questions there. So here one question I am giving you, this one, as an assignment, and you people need to submit it on the blackboard. Okay, this is I will consider for your participation marks. So here you can see, find the current passing through 2 ohm resistor using superposition. Okay, deadline will be Thursday, inshallah. Thursday.
Okay.
Okay, just a minute. G, yeah, not Thursday, Saturday, sorry. Saturday, deadline will be on Saturday. So this is one thing here, okay? So you know that this is the resistance. Here you need to find the current passing through the 2 ohm resistor. Okay, so one question is this. Another question is this. Superposition theorem. So find Ix, Iy. This is Ix. This is Iy. I need all the steps. I don't want the answer. I need the steps, how you are solving it. Keep in mind. So it should be fully solved with all the explanation how you are solving. It's not about the answer. Answer you can just check in the false state. You just make it there and you can get the answers. I need the steps. First consideration, second consideration, then calculation, adding and all. Okay. So it will consider, your marks will be considered for the participation. 1 mark will be like that. So I will open the link and you can upload by Saturday. Clear? So this way we have done with this chapter, girls, and questions are simple here. You can easily find, the quiz questions are very simple. You can easily get it. One is just interesting. I think this one. Check this one. Okay, yeah, for this one, you can take the picture of these questions. 1 minute, just take the screenshot of this question because you need to solve it. It's not there in your, so take a screenshot.
We did.
Okay, and this one. Okay.
Okay.
All right. Yeah, so you can go for all the quiz, no problem. 2 circuits that are equivalent have the same number of components, response to electrical stimulus, internal power dissipation, all of the above. If the 2 circuits are equivalent, what they will be having? Response to electrical stimulus. Yeah, B. Yeah, because it's about if you apply a voltage source, so how much total current will be there, how much total power. It's not about internal power dissipation, it's all about stimulus. Second, okay, yeah, series, yes, so you can apply voltage divider and you can also apply Kirchhoff's voltage law.
D.
D. Okay, R2 parallel with R3. Okay.
C.
R2 is in parallel with R3. Yes, they are parallel because connected between 2 common nodes. C. This one you can calculate. Simple. Just apply Thevenin what they are asking. You can calculate yourself. This one, Kirchhoff voltage law. For the circuit shown, Kirchhoff voltage law apply only to the outer side loop, applies only to the A junction, can be applied to any closed path, does not apply. Can be applied to any closed path. Yeah, and it could be outer loop, inner loop, whatever. It should be closed path, so we can apply anywhere. The effect of changing a measured quantity due to connecting an instrument to a circuit is called. We have a circuit and we connect something, so it is called loading. Yeah, correct. Because yeah, once we connect the load, you know that overall resistance will reduce because they connect in parallel. That's why. So it will change the quantity. Four volts. How did you calculate 4 volts? KVL. Okay, so which closed path you use for KVL? So what is the closed path which you apply? You can apply this way, and this is already, so we'll go this way.
Yeah, then to the right.
Then
Right.
through RL.
Yes.
Then
Down.
here.
Yeah.
And this. Yes.
That one. Yeah.
Yes, this is correct. We can apply this way.
Okay.
Okay, so this way 12 minus 7, then minus 1, then you will be getting this 4. This is the correct. All right, let's see now. Answer is 4. Okay, now see this one. So this time assume R2 is adjustable with the stone bridge and with stone bridge is balanced. Now it is balanced. At this point, the voltage across R4 is measured and found to be 5 volts. Okay, the voltage across R1 now, how much it will be there now, R1. And they are saying with stone bridge is balanced now.
Same path, right? So 12 minus.
Yeah, we can apply same path. Yeah. But how much is the voltage drop across RL if we apply same path? Same path if you are applying, how much is the voltage drop across RL? How much is the drop across RL? Yeah, it is 0 because of the balance condition. It is 0. So 12 minus 0 minus 3, you can get it. And how much is the answer? 7 volts.
7 volts. Yeah.
Yeah. Okay. All right. Finally, this one.
B.
Resistance equal to, yeah, but okay, khalas. The load resistance is equal to the source resistance. This is the way. All right. So these are some problem sections. You can go and check in the book and you will find other questions also. So this way we have done with this chapter, girls, and inshallah we'll start new chapter next week. Now you can practice and give